So in this video, I'm going to be doing a few problems from the worksheet um, where we're going to be using actually every single one of these equations that I have listed here. This is our base equation, acceleration equals change in velocity over change in time, which can expand into acceleration equals final velocity minus initial velocity over change in time. And I'll call this equation Roman numeral 1. From this, we derived all the other equations, including change in velocity equals acceleration over time, equation Roman numeral 2. Change in time equals change in velocity over acceleration, which equals final velocity over initial velocity over acceleration. It's equation 3. Then we had final velocity equals the quantity acceleration times change in time plus initial velocity. It's equation Roman numeral 4. And finally, initial velocity equals final velocity minus the quantity acceleration times the change in time. And that's equation 5. And put the little arrow there. Okay? And so I'm going to have these problems from your worksheet, and we're just going to start going through and going through the steps of how to answer word problems. And remember, the first thing you want to do is you want to find out what's being asked. Okay, what are they asking for? The second is what equation are you going to be using of these 5 equations? The third thing is you want to find out what is given in the problem. The fourth step is you want to plug in or substitute with units. Let me put that in big letters. With units. And then the fifth is solve. Okay? Or use your calculations. And so let's do number 5 first. And so the first thing is Stephanie's running down the street at plus 10 meters per second. She sees a double tall latte on the road ahead of her and starts sprinting. After 5 seconds have passed, Stephanie is running at plus 15 meters per second. Assuming she does not change direction, what was Stephanie's acceleration? The first thing you want to do is you want to see in the question mark sentence, what is the question asking for? Well, in this case, it's asking for acceleration. Okay, that is what they're asking for. So because it's asking for acceleration, we know that we can use this equation right here. Acceleration equals change in velocity over change in time. And so that's the first thing I'm going to do is I'm going to write down that equation, and I'm going to say acceleration equals change in velocity over change in time, except I'm going to expand it, and I'm going to say equals final velocity minus initial velocity, all divided by change in time. So that's the second step. That's the equation I'm going to use. Now I have to look and see what's given. Okay, so I know that I need acceleration. That's in blue. Okay, I need to find final velocity, initial velocity. And how you do this is you want to look for units. And we know the units for velocity. The units are going to be in a distance over, a displacement over a time. So meters per second, usually what you'll see, or you're going to see kilometers per hour with a vector. And so if I look here, I see meters per second here, and I see meters per second there. That's how I know that those are velocities, just by the units. And so I look here, she's running down the street at plus 10. This has got to be her initial velocity right here. Her initial velocity has got to be plus 10. So that's going to be her v sub I. Because it says after 5 seconds have passed, Stephanie is running at 15 meters per second. So after, meaning at the end, she's now running 15 meters per second, and so that's going to be my final velocity. So good, so I got those top 2 taken care of. Finally, I'm looking for a change in time. Time has a units of seconds, right? Or hours or minutes. And so the units here, I'm looking probably for seconds, and I see it right here, seconds. Units are the key. I keep wanting to emphasize that because if you see units and know your units, you can help identify this stuff and make this easier to do. So 5 seconds, this is going to be your delta t. All right, we have VF, we have VI, V sub I, we have delta t. Now we just got to plug in. So final velocity is plus 15 meters per second. And the initial velocity, I'm going to subtract that, plus 10 meters per second. and I use these parentheses because I want to make sure I include the direction, which is the positive, in front of these numbers. And then divided by change in time, which is 5 seconds. All right. And now I'm going to solve this. Plus 15 minus plus 10 is simply plus 5 meters per second divided by 5 seconds. Now all I have to do is work out the math, and this will be plus 1 meters per second over seconds, or over 1 second, and that'll be the final answer. So we did all 5 steps. What question's being asked? Acceleration. What equation do I use? A equals v sub f minus v sub I over delta t. Plug in the numbers that's given. I'm sorry, what is given? 15 meters per second vf, 10 meters per second plus 10 meters per second v sub I, 5 seconds delta t. Plug them in into the equation. Plus 15 meters per second minus plus 10 meters per second divided by 5 seconds. Work it out. Plus 5 meters per second over 5 seconds is plus 1 meters per second. So I'm not going to go through all of that in these next few ones. I just wanted to walk you through number 5 so that you understood exactly how we do these. So let's do the next one, number 8. Gabe throws a pumpkin onto a porch. At first, Gabe is holding the pumpkin motionless 0 meters per second. 2 seconds later, the pumpkin leaves Gabe's hands traveling at plus 300 meters per second. Assuming it does not change direction, what was the acceleration of the pumpkin? So again, what's the question being asked here? Here's the question mark. It's asking what was the acceleration? Acceleration. So I know I'm looking for acceleration again. And so that means I'm going to be using the same equation right here. Acceleration equals final velocity minus initial velocity over change in time. So let's write that equation down. Acceleration equals v sub f minus v sub I all over delta t. Now, sometimes there's multiple equations for the same quantity. So let's say they're asking for acceleration, you know another equation for acceleration. Well, then you're going to need to make sure you see what's given. And so I see here meters per second, it's a velocity. Meters per second, that's another velocity. And I see seconds, that's a time. Okay? This has got to be the initial velocity. He's holding the pumpkin motionless. There's v sub I. 2 seconds later, is the pumpkin leaves and it's going at 300 plus 300 meters per second. That's v sub f. And again, 2 seconds later, this is your time, delta t. Okay, we have everything we need. Let's plug in and solve. So v sub f plus 300 meters per second minus v sub I, 0 meters per second, okay, divided by 2 seconds. All right. So from this, we could just do the math right away. Plus 300 meters per second divided by 2 seconds. This will give you plus 150 meters per second per second. And that is your answer. So these are pretty simple once you figure out how to do them. Let's look at number 9. Number 9 says, a bicycle accelerates at plus 1 meters per second during a 4-second interval. What is the change in the velocity of the bicyclist and the bicycle? Well, the question mark says, what is the change in the velocity? Change in the velocity. Sounds familiar. We know change means delta. Change in what? Change in the velocity. This problem is asking for delta V. And if I look back up at the top here, there you go. Delta V equals A times delta T. That's the equation I'm going to use. All right. So I'm going to say delta V equals A times delta T. Well, let's see if I can't find my acceleration. But wait a second. Meters per second per second. That's a velocity over a time. This is going to be your acceleration right there. 4 seconds. Seconds is a unit of time. It's got to be delta t. Okay, and so now just got to plug in and solve. So this equals plus 1 meter per second times 4 seconds over 1. I'm going to do that. And so what I see happens here is that these seconds cancel. Seconds over seconds will cancel. And I always like to write things in a fraction form so that I can see how my units cancel. And so my final answer is simply plus 4 meters per second. Those are the units that I have left after I cancel out those seconds, and so I see that those meters per second are my units of velocity. So it's a reasonable answer. Okay, moving on to number 10. A car can accelerate at plus 2 meters per second. How much time will it take to velocity up from plus 1 meter per second to plus 11 meter per second? And so I look here, and it's asking, question mark, how much time? How much time? And so time is what I'm looking for. And so I'm looking for delta t. That's what the question is asking for. I look here and I see a couple of units of velocity, meters per second, and I also see some units of acceleration, meters per second, a velocity unit over time. And so I remember my equation for delta t that I derived earlier is delta t equals delta v over a, which equals final velocity minus initial velocity all over acceleration. So I'm going to use that expanded equation right here, delta t equals vf minus vi all over a, for this problem. And so if I look here, delta t equals v sub f minus v sub I all over a. And now all I have to do is plug in. So I have to determine from 1 meter per second to 11 meters per second. So the 1 meter per second, this has got to be my v initial. And then this 11 meters per second is going to be my v final. So it's going to be the quantity plus 11 meters per second minus, parentheses, plus 1 meter per second, all divided by acceleration, which is plus 2 meters per second. Now what I'm going to do here, I've shown you guys before, but I'm going to make this over 1. Instead of, if I take the number plus 1 meter per second all over 1 second, to divide by that, I'm going to take the reciprocal of it, and so I'm going to multiply it by the reciprocal. That's how I divide by this. I'm sorry, it should be plus 2, excuse me. What did I do there? Sorry. Eraser. Here, plus 2, excuse me, meters per second. So I'm going to flip it. So I am going to multiply by the reciprocal of plus 2 meters per second, which would be times 1 second over plus 2 meters per second. So again, I take the reciprocal of this, I just flip it, which is the reciprocal, and if I multiply that, it's like dividing by plus 2. The reason I'm doing this, I'll show you, is so that I could cancel out my units. And so I can see that meters per second are going to cancel here. And then I will have plus 11 minus plus 1, which is going to give me plus 10 times 1 second, seconds, divided by plus 2. Okay? And so from there, I know 10 divided by 2 is going to equal 5 seconds. And that's my final answer. Okay? So remember that, there's a way you could just put, 2 meters per second, but I wanted you to see how we get seconds into the numerator. And we do it because dividing by a fraction is the same thing as multiplying by the reciprocal. Okay. Hold on one second. There we go. Okay, so on to number 11. Freight train traveling with a velocity of plus 10 meters per second begins braking as it approaches a train yard. The train's acceleration while braking is negative 0.5 meters per second per second. What is the train's final velocity after 30 seconds? First thing we gotta do is gotta look at the question mark. What is the train's final velocity? It's asking what is the final velocity. So this is what I need to know. I know my equation will be v sub f equals, all right? And I know from my previous calculations in numbers 1 to 4, v final equals the quantity a times delta t plus v sub I. Okay, so let's look at the equation and see what's given. We see meters per second here. It's traveling with that initial velocity, so this has got to be my v sub I right here. I can see negative, it says the train's acceleration while braking. So all right, it already tells me the acceleration while braking is negative 0.5 meters per second per second. So I know this is my A. All I need now is my delta t after 30 seconds. So this right here is my delta t. That's what's given. There's my equation. Let's plug in. Okay. So I go here. Quantity A is negative 0.5 meters per second So I'm going to write that in a fraction form. Negative 0.5 meters per second over 1 second times 30 seconds over 1 quantity plus v sub I, which is plus 10 meters per second. Okay. And so at this point, let's look at what we have here. We could see that seconds are going to cancel here. Okay. And so we know that v sub I is going to equal negative 0.5 meters per second times 30. So basically half of 30 is 15. It's a negative. So it's going to be negative 15 meters per second plus 10 meters per second. So plus 10. So they're vectors. So negative 15 plus 10, that's going to give me a negative, oops, this should be v final, excuse me. A negative 5 meters per second. Now, let's think about this for a second here. So, if the freight train is traveling with that velocity, and then it begins braking, will the brakes cause it to go in the negative direction? So it's moving to the right, plus 10 meters per second. Now, this answer tells me that it's moving to the left, negative 5. When putting on brakes, you're not necessarily going to cause the car to move in the opposite direction. And so one of the things you have to think about here is, even though VF is going to calculate to negative 5 meters per second, we know that brakes will not cause a vehicle to move in the opposite direction. So actually, the final answer is going to be 0 meters per second. It's going to be stopped. And the reason it's going to be stopped is because after so much time, those brakes will stop the train and it will not be going in the opposite direction. It'll just be stopped. And so we could talk about more of that in class. But that's the final answer, 0 meters per second, even though the calculated final velocity is negative 5 meters per second. All right, last problem, number 12. An automobile accelerates at plus 2 meters per second over 6 seconds to reach freeway velocity at the end of an entrance ramp. If the car's final velocity is plus 30 meters per second, what is its initial velocity when it began accelerating? Question mark is right here. What was its what? its initial velocity. What was its initial velocity? That is going to be what we're looking for. We are looking for v sub I. All right, so v sub I, we know from our equations up top, initial velocity is equal to final velocity minus the quantity a times delta t. A times delta t. And so all I have to do now, whoops, it's all right. I can do this quick. V sub I equals v sub f minus a times delta t. So now we got to see what's given. So I'm looking here. An automobile accelerates. It tells me what this is. It accelerates at plus 2 meters per second per second. This is my A. Over 6 seconds. 6 seconds, that's going to be my delta t. All right, to reach freeway velocity. If the car's final velocity, so it even tells me, this is my final velocity. It's 30 meters per second. That's v sub f. And so that's all I need. V sub f, A, delta t. Let's plug in and solve. Hurry up before my battery runs out. V sub f plus 30 meters per second minus A is plus 2 meters per second. Quantity plus 2 meters per second times delta t, which is times 6 seconds over 1. Shoot, it should be like this. All right, I can see what cancels here, right? Seconds cancel. So you're left with 2 times 6. So let's work this out. So this will be plus 30 meters per second minus 2 times 6 is 12, right? 12 meters per second. Seconds cancel. 30 minus, that should be a plus, excuse me. 30 plus 12 will equal plus 18 meters per second. And that's your final answer. Sorry I did it in purple. It should be in black. There you go. We'll box it in orange. Good enough. Plus 30 minus 12 is plus 18. Okay, so that's it. I hope this was helpful. If you have any questions, give me an email, and I'll see you in class.